We're here at CATL's Z Factory, and we're here to find out how to turn this bag of powder, lithium and magnesium and other metals.
CATL just dropped a bombshell on the EV industry, unveiling its second-generation solid-state batteries, and this could be game over for Toyota. While Toyota has been hyping up its future battery tech, CATL just made it a reality. These new batteries promise longer range, faster charging, and insane durability, pushing the boundaries of what's possible. If Toyota was banking on its solid-state breakthrough to dominate the EV market, this latest move from CATL might have just shattered their dreams. So what makes these batteries so revolutionary? Let's break it all down. Sodium-ion battery revolution. Imagine a future where the batteries powering our devices, cars, and even entire cities are no longer dependent on a scarce and costly resource. That's where sodium-ion batteries step in. According to AI predictions, these new power sources aren't just an alternative to lithium-ion batteries. They're poised to overtake them by the end of this decade. But this isn't just a simple swap of materials. It's a complete transformation of how we store and use energy, a shift that could reshape the world's power systems. For years, lithium-ion batteries have been the backbone of modern technology, fueling everything from smartphones to electric vehicles. But there's a catch. Lithium is becoming harder to find. The global demand for lithium has sparked an intense competition, with countries scrambling to secure enough of this precious element before supplies dwindle. The world is running out of lithium faster than expected, and the race to find an alternative is more urgent than ever. Enter sodium, the unsung hero of the periodic table. Unlike lithium, which is mainly found in specific locations and requires extensive mining, sodium is everywhere. It's a key ingredient in table salt, abundant in ocean water, salt flats, and even beneath our feet. This widespread availability makes it a game changer. But sodium-ion batteries aren't just about being cheaper or easier to source. They promise a more stable, sustainable energy future. However, having abundant material isn't enough. For sodium-ion batteries to truly compete, they must meet or exceed the performance of lithium-ion batteries. That's where cutting-edge innovation comes in. Instead of simply replacing lithium with sodium, scientists and engineers are rethinking battery design from the ground up. Leading this revolution is CATL, the world's largest battery manufacturer. They're not just making batteries, they're redefining energy storage. Their second-generation sodium-ion battery isn't just a contender, it's a serious threat to lithium's dominance. This battery is pushing past previous limitations, particularly in energy density, which determines how much power can be stored in a given space. For years, sodium-ion batteries struggled to match lithium's efficiency, but CATL's breakthrough technology is closing the gap. Their latest battery aims to exceed 200 watt-hours per kilogram, bringing it on par with the best lithium iron phosphate (LFP) batteries. This isn't just progress, it's a massive leap forward. And there's more. Sodium-ion batteries perform exceptionally well in extreme temperatures, making them more reliable in harsh conditions. This advantage alone could make them the preferred choice for industries and consumers alike. The future of energy storage is no longer set in stone. It's an open canvas, and sodium-ion technology is painting a bold new picture, one where power is abundant, sustainable, and no longer tied to the limitations of lithium. As the transition is happening, could the age of sodium-ion batteries be fast approaching? Let's find out. Impact of sodium-ion battery on EV market. Sodium-ion batteries are emerging as a game changer in energy storage, capable of functioning in extreme conditions where traditional lithium-ion batteries would fail. These batteries can operate in temperatures ranging from a freezing -40 degrees Celsius to a scorching 80 degrees Celsius, making them incredibly reliable for real-world applications. Whether enduring the sweltering heat of a desert or the bone-chilling cold of the Arctic, sodium-ion technology is built to withstand the harshest environments. But it's not just about durability. Sodium-ion batteries are also much safer. Unlike lithium-ion batteries, which are prone to thermal runaway, a dangerous chain reaction leading to overheating and fires, sodium-ion batteries are far more stable. This significantly lowers the risk of explosions or battery fires, making them a more secure choice for energy storage. This isn't just an improvement in safety, It's about creating trust in the technology and ensuring that the future of clean energy is not only powerful but also reliable. However, performance alone isn't enough to drive a widespread shift in technology. Cost is a crucial factor, and this is where sodium-ion batteries shine. They are projected to be far cheaper to produce than lithium-ion batteries, even as lithium prices fluctuate. The affordability of sodium-ion batteries isn't just about reducing manufacturing costs. It's about making clean energy accessible to everyone. By lowering energy storage costs, these batteries have the potential to revolutionize global energy markets, putting renewable power within reach for more people and industries. Leading companies like CATL are heavily investing in scaling up sodium-ion battery production, developing new manufacturing infrastructure to support this growing technology. Sodium-ion batteries are expected to have an immediate impact on several industries, particularly in the electric vehicle (EV) market. While high-performance EVs may still rely on lithium-ion batteries for now, sodium-ion technology is ideal for smaller, budget-friendly electric vehicles, making them more accessible to a broader range of consumers. Beyond EVs, sodium-ion batteries are especially well-suited for large-scale energy storage systems, particularly in regions with extreme temperature fluctuations. This makes them a perfect fit for power grids, ensuring stable and cost-effective storage for solar and wind energy. The rise of sodium-ion batteries could have far-reaching consequences for the global energy landscape. By dramatically reducing the cost of renewable energy storage, they could make solar and wind power more competitive than ever, further weakening the economic case for fossil fuels. This shift could accelerate the decline of the oil industry and pave the way for a cleaner, more sustainable energy future. It's not just a technological change. It's a transformation in how the world generates and stores power, moving us toward a more just and sustainable society. Experts predict that sodium-ion technology could replace up to 40% of current lithium-ion applications, diversifying and strengthening the global battery market. Unlike lithium-ion batteries, which are vulnerable to supply chain disruptions and geopolitical tensions, sodium-ion batteries rely on sodium, a resource that is abundant and widely available. This reduces dependence on rare and expensive materials, ensuring a more resilient and secure energy future. But for this transition to succeed, several challenges must be overcome. Scientific advancements, large-scale production, and integration into existing energy systems are all necessary steps. This isn't just about developing a new type of battery, it's about reshaping the entire energy landscape. It requires commitment from researchers, manufacturers, and policymakers alike, all working toward the shared goal of a future powered by clean, affordable energy. If these hurdles can be overcome, sodium-ion batteries could become the backbone of the global energy transition. They represent not just a breakthrough in battery technology, but a fundamental shift toward a more sustainable and equitable energy system. This isn't just about the next big innovation. It's about the choices we make today to shape a better world for future generations. The era of lithium is nearing its end, and the era of sodium is just beginning. This isn't speculation, it's a revolution, one driven by innovation, sustainability, and the urgent need for a cleaner, fairer future. Sodium, the sixth most abundant element on Earth, is now taking center stage in the energy revolution. But raw materials alone don't change the world. Innovation does. With innovative design and engineering, could sodium-ion batteries be paving the way for a future where clean energy is accessible to everyone? Let's take a closer look. Sodium-ion battery breakthrough. The breakthrough achieved by CATL with sodium-ion batteries represents a major shift in energy storage technology. Instead of relying on traditional lithium-ion chemistry, scientists have reimagined the battery structure using a Prussian blue cathode. This innovation has resulted in a sodium-ion cell that not only competes with lithium-ion batteries in energy storage, but in some cases even surpasses them. The Prussian blue cathode offers excellent stability over repeated charging cycles and delivers impressive charging speeds. When combined with a hard carbon anode, this technology is now poised to take center stage in the battery revolution. However, for any breakthrough to gain widespread acceptance, it must continue to perform under real-world conditions. CATL has taken sodium-ion technology to the next level by enhancing its resilience to extreme temperatures. Winter testing has revealed that these batteries can function efficiently in temperatures as low as -40 degrees Celsius, outperforming lithium-ion batteries in severe cold. This ability makes sodium-ion batteries an ideal choice for regions with harsh winters, ensuring reliable power storage for electric grids and vehicles even in the most challenging climates. But temperature tolerance isn't the only factor that sets sodium-ion apart. Safety is another critical advantage. Unlike lithium-ion batteries, which have a higher risk of overheating and catching fire, sodium-ion batteries are far more stable. In rigorous nail penetration tests designed to simulate dangerous conditions, sodium-ion cells remained intact, passing without any safety incidents. This is a major win in a world where battery safety is under increasing scrutiny, especially with the rising demand for energy storage in homes, businesses, and electric vehicles. Beyond safety and performance, affordability plays a huge role in mass adoption. Sodium-ion technology is expected to significantly reduce battery costs. By 2030, experts predict that production costs could drop below $100 per kilowatt-hour, making sodium-ion batteries up to 80% cheaper than lithium-ion alternatives. This cost advantage is driven by the abundance of sodium, which is easily sourced from seawater and salt deposits, unlike lithium, which requires intensive and often environmentally harmful mining. If sodium-ion production is successfully scaled, it could reshape global energy markets by providing a cheaper, more sustainable alternative to current battery technologies. However, transitioning from laboratory success to widespread commercialization is no small task. To truly challenge the dominance of lithium-ion batteries, sodium-ion cells must prove their durability over thousands of charge cycles without losing performance. This requires meticulous engineering, extensive real-world testing, and continuous refinement. Additionally, building a global supply chain for sodium-ion batteries demands massive investment. Billions of dollars will need to be poured into new manufacturing facilities, known as gigafactories, to produce these batteries at the scale required for mass adoption. While progress may be faster than the decades-long rise of lithium-ion, patience and persistence will be key to making sodium-ion a global standard. Yet, even as sodium-ion technology advances, challenges remain. Existing lithium-ion infrastructure cannot simply be repurposed to manufacture sodium-ion batteries. New production equipment, refined supply chains, and specialized expertise will all be necessary. Companies investing in sodium-ion technology are making a bold financial gamble, as the technology is still in its early stages. Another hurdle is recycling. While lithium-ion recycling systems are already being developed, sodium-ion recycling methods are still in their infancy. A robust recycling network will need to be established before sodium-ion batteries can be adopted on a global scale. The competition between lithium-ion and sodium-ion technologies will be fierce. The lithium-ion industry has a decades-long head start, boasting an extensive patent portfolio, advanced research and development capabilities, and a well-established global supply chain. Sodium-ion pioneers must prove beyond a doubt that their technology is not only viable, but superior in key areas. They must also demonstrate that it is worth the substantial financial investment needed to replace lithium-ion's dominance in the battery market. Despite these obstacles, the rise of sodium-ion batteries marks the beginning of a new era in energy storage. This is more than just a scientific breakthrough. It is a social and economic shift that could redefine how the world powers its future. With sodium being far more abundant than lithium, and its extraction process being less harmful to the environment, the promise of a more sustainable and equitable energy landscape is within reach. Additionally, sodium-ion batteries have the potential to revolutionize industries beyond electric vehicles, extending to grid-scale energy storage and even portable electronics. Their ability to function in extreme temperatures and their superior safety profile make them a strong contender for replacing lithium-ion in many applications. Ultimately, the transition from lithium-ion to sodium-ion batteries is not just a technological upgrade, it is a step toward a cleaner, more sustainable world. If the necessary investments are made and challenges are systematically overcome, sodium-ion technology could make renewable energy storage cheaper and more accessible for everyone. What do you think about CATL's breakthrough in sodium-ion battery technology? Let us know your opinion in the comments section. Don't forget to like and subscribe.